many of you I know, especially the people who are here. Josh Rayeske, I'm now with LJB Product Solutions. Been working with LabVIEW for quite a while. Been doing presentations before. If you don't want to hear me talk, volunteer to give a presentation so that I don't. This one came up quite a while ago. We were talking with Greg and I. This was probably before COVID. We were yapping about communicating with other stuff. And it just never came to. So I threw that out there when you had asked for presentation ideas. Let's try communicating. Mainly trying to get LabVIEW to talk to a PLC. So what you really need are matching hardware and matching protocol or software protocols. So hardware options, you've got the basics like the serial RS-232, straight point-to-point, 422, 485. You get a little bit more with many-to-many or one-to-many. Ethernet, that's a wide, a lot of different things can be Ethernet. And then there's also CAN, Control Area Network. And when I originally had said CAN, I was thinking entirely automotive, completely skipping the CAN open for the industrial networks and stuff. So I did quick download the industrial CAN for LabVIEW, and it's very different from their XNet protocol or API, so I didn't bother writing too much about it. When it comes to the actual communication protocols, there's all sorts of things there too. There's the proprietary stuff. There's Skippy. I say it's the standard communication for programmable instruments. It's one where you have the capital MES, colon, volt, colon, something. Modbus. I was told by a vendor a few weeks ago that Modbus was old and nobody uses it anymore. Well, I see it on everything, with the exception of Rockwell. And it works great for communicating back and forth with PLCs. As long as you're just trying to exchange numerical data when you're trying to do strings, it's very poor, but often you're trying to get string data out of a PLC. Modbus comes with the two forms, the RTU, which is over the 485 protocol, and then TCP over Ethernet. And then very prevalent one in this country with Allen Bradley stuff is the EthernetIP. Serial one-to-one is RS-232. You got one thing sending, one thing receiving. Because of that, you got the little table on the side there with what the typical pinout is for at least a 9-pin sub-D connector. The basic ones you need are pins 2, 3, and 5. Your transmit data, your receive data, and then your reference ground. Some particular hardware, they need hardware handshaking, and that's where the DTR, the DSR, RTS, CTS all come in. For the particular PLC that I brought, which I don't have the mating connector for, that one just uses the 3 pins, the RXD, TXD, and ground. So I guess when you're talking to anything, you got to look at their data sheet. LabVIEW is capable, and any serial port USB thing you buy is capable of handling any of this. So when you're doing your configure serial port, you're going to have that flow control option, the parity, how many data bits, how many stop bits, and your baud rate. Get all of that stuff to match whatever you're trying to talk to. When you're programming LabVIEW, you have all the control. Whatever you're talking to, that might be fixed. So. I kind of am going to skip right past 422 since I don't know if there's a whole lot out there that does that. But 485, you're using kind of the same thing, a serial port they call it, but now you can have multiple senders, multiple receivers on the same bus. It's complicated more. You're going to have 2-wire networks and you're going to have 4-wire networks. The 4-wire, you just have twisted pair for both your transmit and your data plus, your data minus. 2-wire, you're sharing data plus, and that's all. But again, your hardware needs to match. So if you have one thing in your network that's going to be a 4-wire and you got a bunch of other 2-wire stuff that may not actually work together, you're going to have to either put a gateway in between or pick a different piece of hardware that matches the rest of your network, or run 2 networks. The USB device that I have here is capable of either or. So right now, this PLC is only a 2-wire RS485. So that's how I have this one wired up to talk to it. Some other catches, you need termination resistors on these. So I don't know if you can make it out in that little tiny mirror. Yeah, don't do that. But you can't leave it open-ended. You leave it open-ended, data's not going to go through right. Network may not even work at all. So a particular PLC that I have has a termination resistor, and it just tells you in the documentation if you wish to enable it, jumper the TX plus or the data plus back to the termination. That'll handle that end. This particular USB device that I have has a termination resistor built into its breakout board, so that made it real easy. If you don't have those things, add a 120 ohm resistor on either side. If anywhere along that network, you should be able to touch between the plus and the minus and read 60 ohms on your multimeter, give or take a bit. If you don't, you're going to have some problem. The other one that's important, twist the wires. I know we hammered that into people at Stratec, especially some of those pieces of test equipment. They would have 30-foot umbilical runs, and in those are number 6 wire that are running the big motors that are controlling the product, and those are pulsed. So you get a ton of electrical noise in those umbilicals, and you have the communication line running right next to them because you don't want to run 30 feet this way and then another 60 feet around. It's a lot of wires. So, but just twisting them helps a whole lot. Shielding them makes them even better. If you do use a shield, only connect one side of the shield. Don't make it a conductor. You just want to drain one side. So for this here, I can... the PLC I have is a Productivity 1000. I won't say a cheap thing. I'll say an inexpensive one from Automation Direct. Work quite well. On the hardware side, I can go to my serial ports, and this one has both a 232 and a 485. For now, I'm just disabling the 232. It's got a goofy RJ10 or RJ12 plug that I didn't bring with me. So my 485, this one gives me a lot of options. I can either have a custom ASCII, disable it, or use Modbus RTU over it. It's got a 19.2 baud. Because it's on a 485 network, I need to give it a node address because there are going to be multiple items on this bus. I'm running no parity and one stop bit. So got that. If I go to my that a second. Let me actually plug the device in. So what I just said, there was an illegal data address, and I was messing around with this too much. I may have deleted some of my Modbus tags. Eight. 13. There. Aha. Great stuff. So, well, you start with an empty array, you're going to send an empty array down to Modbus, and it doesn't like that. Well, for you online, you're not going to be really able to see, but I have a couple of just simulated switches on this. So as I click them on the front of the PLC, see that they're coming across. And as I click on here, you might be able to see on this module here, the output's lighting up. And I think if I click the first one, you'll get the very loud relay click. So all that really took was, one, using the NI Modbus library that you can download through VIPM. configuring the serial with the same stuff. It's over RTU. It's going to unit ID 10. It's got a 19.2K baud rate and no parity. Same thing as my settings over here. So say, make a match and you're good. And then the other one that's important for Modbus is that you actually have addresses that exist. So with the productivity, you're able to map anything to really almost any Modbus address. Discrete inputs are going to go to the discrete input types of Modbus registers. Analog inputs will go to the input registers. And then you have the option with coils and holding registers for writing down U32 data or binary data, bit stuff. If one of the catches on some of these is if you have gaps. So like here, this application, I'm programming both the PLC and the LabVIEW application. It's much nicer in Modbus. You can read up to 250 data elements at one time, one go. It's a lot more efficient than doing 250 reads. But if there is a gap in your data, you can end up getting an exception for an illegal address because nothing exists there. So I just deleted my discrete input number 4. So if I resend that down, I'm going to get an error on this side here. Well, let me just rerun it. Maybe I won't get an error. Maybe, you can't see the switch because I deleted it, but it won't error out. Some PLCs will. If you don't explicitly say that this Modbus address exists, it will say there's an illegal address requested, and it'll fail out on you. So, yes, score 1 for productivity on that. If you are talking, I do have a single board Rio up here too that has, I'm running a Modbus slave on it. The nice thing about the NI Modbus library that you can download from VIPM is once you launch it, it's basically all of them are available. It has no gaps. There's stuff that you write to or don't write to, but yeah, you really don't have the address exception errors that'll come up. So yeah, there's the top one is the host PC, bottom one is the SB Rio front panel. Granted, I am connected to it 2 different ways through the IDE as well as through Modbus, but if I tweak the analog pot, you can see the AI6 is changing. Hit some push buttons. See that goes. So I know this is for communicating with PLCs, but if you do have a simple real-time application and you're not trying to exchange too much with, I mean, definitely use network streams or something else if you're pushing a whole bunch of data. But if you're just trying to get some discrete I/O, this is pretty simple to implement, and it's already a proven communication protocol. Kind of jumped ahead on what I was doing there, but Ethernet, a lot of people say, communicates over Ethernet. Okay, what? Like, that doesn't tell me much. So you can use TCP/IP, although from what I've done on PLCs, I hate working with string data. It is kind of a pain in the butt. It's not like in LabVIEW where you can trim the string, you can convert it to whatever type of data type you want, however you want. On the PLC, that seems to be just a little bit more cumbersome for me. But most of them do have the Modbus available. And then EthernetIP is the other big one. Profinet from Siemens, I believe that one takes, I don't know if you can just use or communicate with Profinet by sticking your Ethernet cable into any generic port. I don't know if that requires a specific Profinet card, because I know NI has like a C-series module for Profinet. They have like certain things for communicating Profinet. EtherCAT, I know you need specific hardware, so not every Ethernet port can support EtherCAT. I believe Beckhoff made EtherCAT. The other catch is the Ethernet expansion chassis for serial are only able to communicate from the serial with an EtherCAT port to the expansion chassis. So don't make the mistake of buying some peripheral with EtherCAT and expect the RT chassis with EtherCAT to communicate with it. There's no API, I believe, in LabVIEW. It may have changed it. I know that was a few years ago when I made that request, but no, it's the EtherCAT is strictly for communicating with an expansion chassis. When it comes down to Ethernet addressing, I've seen this mistake happen before, but you got to be on the same subnet. Everyone knows what the networking is, right? Subnets here. But I just liken it to, you got a city, state, city, street, house. And a lot of times with our little networks, we're trying to have a block party. So we want everyone on the same street to be talking to one another. I've seen a lot of people put the exact same address for two different devices. Well, that's just going to blow your whole network up and nothing will work. And then, yeah, that subnet is saying that 255 is saying that the state, the city, and that street number all must match to be able for those devices to communicate with one another. So, yeah, more to ModbusTCP. There's the client and server, or master and slave was the old terminology, and it's still used on the libraries that are available. You got the screed inputs. Those are read-only coils. You can read, write. I guess they're read-only from the master perspective or from the client perspective, so from your LabVIEW application. Coils are able to read and write to input registers. Those are also read-only. Holding registers are read-write. For each one of those four items, you get 10,000. So there can be 10,000 discrete inputs, 10,000 coils, 10,000 input registers, and 10,000 holding registers. So a lot of data is available. Registers are all U16. Somebody did mention it to me that Modbus is old, and yeah, it's that old that that's all that they had when they created it was 16-bit numbers. They didn't have 32-bit numbers on those systems. You are able to transfer 32 bits, so of course. You can just say these two registers make up one number. A lot of them, I know you're big with Cole Morgan. Cole Morgan, everything in their Modbus was two data registers regardless of what the actual value was. And that would kind of throw us off because we didn't know any better. I didn't know any better when I was first starting to do this stuff. So I'm like, yeah, you read two, what the heck? And yeah, you got to learn how to put numbers back together and get them in the right order. Some of these on this particular PLC, I know if I did a Modbus read, it gives me the checkbox to swap the words. Because that's what's going to happen is your big endian, little endian, the PLC might be sending you it with the lowest indexed element is the least significant, and the upper index one is the most significant. And LabVIEW may interpret it the other way around, and now you have a garbage data. So it's easy in LabVIEW to do the swap bytes or swap words, and many of the PLCs, or this PLC, will allow you to do the same thing so that we're transmitting the same way. Other data conversion to go from float to a U32 number as the IEEE 754 standard. If anybody's ever had to deal with that before. So it's just make a new one here for fun. Where's my floats? So close. All right, so now we have a 32-bit floating point value. You can see it's at Modbus register 50, and it extends to 51. It's going to take up two registers because it's a 32-bit number. One of the other catches here is this particular PLC starts its Modbus counting from 1. LabVIEW library starts its counting from 0. So that can throw you off a time or two. Let me PLC. There go used to be crown over there into there. That. So just reading it straight through as a couple of U32s, you're going to get something that looks like garbage. Definitely not the 55.55 that I had written down. So for now, we need to one had to get it into the U32. U32. Oh. Let's replay the game of swap words. Here we go. But this particular typecast, if you go into the help, it'll show you that it does follow the IEEE when you're trying to convert between I32s and single precisions. If you do double, it abandons that whole concept. But yeah, and same thing, if you have a single, you can straight typecast that into an I32. Again, if you're writing it back down to the PLC through Modbus. There again, careful of reading or writing to non-specified addresses. That's sometimes PLC specific, sometimes not. And also be careful, does the device you're talking to start at 0 or do they start at 1? LabVIEW always starts at 0. So at least they're very consistent on that. Then we get into Ethernet IP, and of course that is very generic as well. Within Ethernet IP, you have two different, your client and your server. Now they call it scanner and adapter because why keep anything consistent? There's also implicit and explicit style messaging. Implicit uses the UDP, explicit uses TCP. And then explicit also has connected and unconnected messages. So there's a bunch of different stuff going on within Ethernet IP when they say something is Ethernet IP. The LabVIEW Industrial Communications toolkit with Ethernet IP only supports explicit messaging and can only be an adapter. So be careful if you are buying a device like a servo drive or anything else that says it's Ethernet IP, LabVIEW won't be able to talk to it. It's also an adapter, and adapters don't talk to adapters. Scanners talk to adapters. In this case, again, you have to configure both ends to match. I mean, not only do you have to be on the same subnet with your IP addressing, but Ethernet IP has what they call an instance ID, and then they're going to have a data size. So Ethernet IP is exchanging basically arrays of data, and you, either the manufacturer who created the adapter is already going to say, I'm expecting 60 bytes of data. These chunks of data mean this thing. So when you want to change the position command of a servo, change these indexes to be that position in these units and change some other bit somewhere else, and I'll execute that for you. As far as communicating back and forth with a PLC, this productivity does support all of the Ethernet IP stuff, so it can be a scanner, and it does support both implicit and explicit messaging, so it can talk to LabVIEW. The fun thing is, just to confuse everybody, the LabVIEW IP library, their Ethernet IP, industrial communications for Ethernet IP library, kind of goes a little bit out of bounds on the names and screws it all up if you're not careful. So that's a NIST toolkit here. So they have what's called I/O data. Ethernet IP speak, I/O is your implicit messaging, not explicit. So that kind of leads you to believe that it handles implicit. It doesn't. That's an explicit thing. And it also has messaging. So this I/O data would be your connected explicit messaging. And messaging, where you would have these get and set single attributes, that's your unconnected message. So you're creating a connection, you're sending something, and you're closing the connection back down. That's all the differences. If you are working with the Rockwell PLC, these up here will work, where you can specifically say, I want to read or write, I can pull that up. I want to read or write to a specific tag with on the PLC. Those do work, but again, I'm going to read and then close. That's it. Or I'm going to write and then close. I don't like opening and closing connections. That's not what they teach us. So I like to use the get and set assembly instance data. So for that, you set up either one of them you want first and just make the other one match. So in this case here, I said, okay, I'm going to produce. So I'm going to send something from this application to the PLC. So the PLC will see that as input data. The instance ID is, I just made up, is 100, and I'm going to send 32 bytes of data. Then within this loop, we've got an array just updating what that data is. Same thing, I've got a consuming. So now I'm taking output from the PLC into my application. I'm going to use instance 150 and again exchange 32 bytes of data. And then with this call here, I'm just going to read what that data array is. And it's going to run until I stop or something goes wrong. On the PLC side, this particular one, you go to the Ethernet IP tab, and I find it easier just to drag over another generic client. I've already done it, so I'm not going to do it again. If you have an EDS, an electronic data sheet, you can import them here, drag that over. You still end up tweaking them a bit, but for this, drag over a generic client. I'm going to talk to my computer, which I happen to have on address 18. The default port number is 44818. Pre-populated that for me. And then when I create a new message, again, IO message, that's the implicit type, where that's where I say it gets confusing with how LabVIEW named their stuff. You can get them wrong. But we're going to add an explicit message. And my requested packet interval time is 200. So that means every 200 milliseconds, it's going to pass data back and forth. It's going to send me the data it knows, and it's going to read the data that I know, or the application written in LabVIEW. Doing this on a Rockwell PLC is very similar. You go down in your tree. I don't have Studio on this computer. I actually don't have Studio. But I know as you go down in the tree, you can drag in a new Ethernet IP generic, And you can do basically the same thing. It's a different looking dialog, but you would specify that it's explicit messaging. You would specify the instance IDs and the size of data and how often you want that data exchange. And then you simply map that to its tags and you're good to go. Here you do this, and then you don't map it to the tags until you're on, in this one, on that particular task or ladder diagram. So I'm just saying, all right, my target to originator, so that'd be my LabVIEW application coming back to the PLC. The PLC is always the originator because it's the scanner. I've got 32 bytes of data going back to some array, and it's on instance ID 100. And the same thing, now I have the originator to the target, so the data output from the PLC back to my application. That's on instance 150 and 32 bytes of data. Okay. It should already be running. And let me just see if what data I have. Well, look. Don't think they it always works when you're doing it on your desk. Not getting it. Perfect. Then again. No connection. There's that problem. Yeah. HTTP address and the other. Really, that one shouldn't matter because it's kind of it's C. See that video appeals. That one is intended. Oh, that's what your deputy said. Oh, your deputy was. Yeah, no, it's the like Tater's 18. Oh, sorry. Oh. If you poke around at it for a while. Normally, that works. Much like the, pardon? Yeah, it better not. Or just bouncing between too many different things. But let me just try one last ditch effort of.
So they ask what sort of tool do you use? They don't. Where sure.
I've done it before, but I'll be honest, I don't understand all the information that's there. It's surprising how much extra data is transferred just to transfer the data you want to, you know.
It could be lenses, the Ethernet on the day. See what for.
Oh, that's right. So you can probably see the lights on the front there going, blinking up and down. Great. I don't know if I mapped anything back though. I did. So yeah, flip on switch 1, I get a 1 value. 3, it's just a binary adder called on. So, but honestly, it's usually once it's working, kind of flaky, but it has been a very, I know we've used it on plenty of product at Stratec. It's been a very robust communication between the PLC and the LabVIEW application. You're back to the same thing that you had with Modbus. You're only really exchanging numerical data. Now, granted, you can make that array. I don't know what the limit is on EthernetIP. I know there's got to be one, but we've never come close to having to find out. String data is still going to be kind of a pain, but always is. Float, you're still going to have to do the same thing because, again, it's exchanging decimal values, not floating point values. So you'll still have to do that conversion. But it does work. It can be done.
You're out here, there.
Which one? The LabVIEW. You buy one of these little CPUs. There's plenty of gateways out there that'll do Ethernet IP to whatever you want. I know there's a company that pops up on my Google search, Real-Time Automation, I want to say, in Pewaukee. They have like gateways for anything to anything, basically. You just tell them what you need and they configure it to do it. But it's probably going to cost more than that little CPU, which is $280 maybe. And not only does it give you the Ethernet IP scanner, the ModbusTCP stuff, but it's a programmable logic controller. Put anything on there that you want. So, yeah, that's what we found. First mistake, well, I don't want to say the mistake, but the first thing we did was we bought a Rockwell PLC and got a license for studio. Spent a ton of money basically to turn the PLC into the middleman so that our LabVIEW application could talk to a servo drive. Then once we learned more, we went that route and used a much less expensive CPU, free programming software, and got the exact same performance out of it. Kind of switching gears again, I said that when I first put CAN in my thing, I was thinking all automotive and forgot about the CAN open for industrial communications. Has anybody ever used CAN for like the XNet API, communicated with any vehicle stuff? I know us. Okay. Do you have any particular interest in it? Vassar, I want to say is their name. They've got a really nice tutorial on their website of what is CAN, how does it work. They go into pretty good detail and they explain it really well. Helped me connect a lot of the dots when we first started doing this. The XNet API and hardware from NI is actually very good. I know other people have used Vector CAN. I know you were using some Ethernet to CAN converter. iNet or something. XNet. So don't know anything about that one, but NI also has a really nice piece of hardware, and unfortunately, they only make it for PCI and PXI, but it's a XNet controller that has both or all three, the high-speed CAN transceiver, a low-speed CAN transceiver, and a single-layer CAN transceiver. Because again, you could say CAN, but then there's all these different flavors of control area networks, and they all must match. CAN high-speed and low-speed are both two-wire, much like the 485 network. They have to be terminated at both ends with a 120 ohm resistor. Single-layer CAN is that. It requires two wires. The actual signal wire and then a reference ground, but no termination between. A lot of the OEMs, the Ford, GMs, the Chryslers, any of the other ones, they're going to create what they call a CAN database. So that's where you're going to say, this is the network. Here's all the nodes that are on the network. Here's all of the, they call them arbitration IDs or IDs of the message. And here's how the data is packed into that message. A CAN frame is a ID and 8 bytes of data. Up to 8 bytes of data. You can shrink it down less, but you can't get any more than 8. So this database will say that front wheel speed is going to come from this ID, and within those 8 bytes, there'll be some truth telling, like is the data reliable or not reliable? So do I have a faulty sensor? It'll have so many bits of data. The database will tell you how to convert those bits back into a real number. Because again, you're just transferring integer values, and that's mapped directly to a floating point. So it'll tell you how to do all that. SAE has the J1939 standard, which was really created for the off-highway market. So you have all these tractors or agricultural equipment, and they have their own stuff going on there, but they buy an implement that's not from them. They'll make implements. And sometimes it's nice to be able to exchange data back and forth. So rather than the implement manufacturers or the OEMs of those off-highway vehicles trying to figure it all out, they all got together and they wrote a SAE standard. So on that one, it takes, again, it still can. It's still, I believe it runs on the low speed. It runs at 25 or 250 kilobaud. Because we have Stratic has the Electrek HD actuators that communicate over CAN. It just says that your ID is built up of something. So there's a certain manufacturing code within those 11 bits or 29 bits. There's a manufacturing code, and then there's like a source. So it's this manufacturer, it's an engine. And now I know that these bytes are the engine RPM and these bytes are the engine temperature, that kind of stuff. So if you're building any implement for it, you can request that you have a certain ID value, and then that's yours, and here's how your data is packaged. So at Stratic, we used Thomson linear actuators. They're Electrek HDs, I believe was the part number or the model name, but they ran on CAN. So we could just send messages over that I want number 8 to extend to this position, and number 8 would extend to that position and feedback over a message. Here I am, I'm at this position. So, but yeah, I'm pretty sure Thomson did design those to be used in our testing application. They were designed to go on tractors and lift large things and move large things. So, pretty sure one time I said it was like Facebook, only reliable. It's a broadcast. It just shares information. So each node will just say, here's everything I know. Do with it what you want, but there's what I know. It's not really sending a command, you do this and tell me what you've done. No, it's here's everything I know. And each node then has it, programmed within it that all this information is coming in. Here's what the system state is. This is what I need to be doing to make sure that the system can keep working. When you're working with the XNet stuff, there's XNet database. XNet database editor comes with it. And what's kind of nice, I think I'll just open up the example one because I don't do anything else. But everything you put in here is available in the programming environment. So it's all exposed through different property nodes. And what I liked about that is once we really got into this, OEMs really like to just change their stuff. So after a couple of model years are out there, because you've got people snooping and they finally figure out that, hey, if I'm plugged into my OBD2 and I can read things, I know that this is my wheel speed. I know this, that, the other thing. So OEMs, just to mess with you, after so many years, they'll switch around IDs and they'll move around data bits within the packet. And then to just say, yeah, here's the model year 2021 version. So what I found is I can go in there and I can change the name to whatever I want. I mean, the OEM has only said, this is the arbitration ID that I'm using, and here's how the data is back. So I could say, well, I'm going to call that wheel speed. And now within the programming environment, I've used a property node to say what ID is my wheel speed. And when I receive a message from that ID, now I can just pop wheel speed up. And if the OEM changes what arbitration ID it is, I just get a new CAN database and I just rename it, and that name is available. So there's a lot of stuff you can do with this to prevent yourself from having to constantly rewrite or update code to support those types of changes. And the other one that really helps is you can set ECUs, so basically how many nodes are on the network. You can create as many of these as you want, so I would usually create a test controller, and I would say this controller is responsible for transmitting these 2 frames, and it'll receive those frames. Anything else that comes across on the network, don't care about it, it'll ignore it. But those are the messages I care about. So if the OEM changes and they want something else on there, I can just add it in on the database and hopefully not have to change too much code, if any at all. When it gets down to it, you have, well, they call them cyclic frames. So create a frame, give it an ID. Again, CAN has either 11-bit IDs or 29-bit IDs, so check that box. How much data do you have? 1 to 8 bytes. And is it cyclic or is it an event? The nice thing about this and with the XNet, if you say it's cyclic and it's 10 millisecond transmit time, you write it one time. You say, here's the data, and the XNet controller will then every 10 milliseconds send that message with that same packet of data. If you need to update the data, you just do a simple write, and the next message that goes out, and every message then will have that new data in there. You don't have to write a loop that's running at 10 milliseconds to try to bang this thing out there. If it's evented data, what that is saying is it's going out one time, and if you happen to send 2 messages with the same ID, they will be separated by at least 10 milliseconds. So that's it. And then within each frame, you can specify signals. So this is how you would say that these bits scaled and offset by a certain thing will make up a certain signal. So that's how XNet can turn all those bits back into a floating point number for you. But yeah, quite a lot there. Could spend a whole darn thing on it. Could probably spend a whole meeting on multi-frame messaging. Again, CAN can only be 8 bytes. A lot of times you need to transfer more than 8 bytes. I've seen it done a couple of ways where if you request diagnostic or DTCs, your diagnostic trouble codes, the ECU will respond back with a certain ID. Arbitration ID, it means that this is a device trouble code, and each frame will be a new code. So if there's 8 codes there, it'll just kick back 8 frames. Because that one doesn't matter. All the data that's pertinent is within that frame, so who cares if you get them a little out of order? It's that code and something. There's other times where the order of the data matters. So there's an ISO standard, 15765-2. Go to the Wikipedia page on that. That uses the 8 bytes of data to structure a long multi-framed message. So the first message will get an upper nibble of 1. You can everything in some hex. So you get a 1. That way you receive it, you know that's the first frame, so there's more data to come. The next byte, actually the lower nibble and the next byte, tells you how many bytes of data are going to be coming. And then the actual data starts. So this 01 over, 01, 02, all the way up, that's the actual data. What you have to do as a controller, you need to reply back with a flow control message. XNet, I've never worried about it. If you send a 3 is the flow control message, and you send 00000, you're just saying, send me all you got as fast as you want. I can handle it. If you're communicating with a device, especially on some of these little embedded micros, they can't handle that. And I got mad at Conti that one time because they would send me a flow control message saying 30,000, meaning go ahead and send it as fast as you want, and it would crash. So they really did need something. So that bytes 1 and 2 can be set with a block size and a separation time. So it can say, just give me 8 bytes of data and separate it by 10 milliseconds, please. And then that tells you on those sequential frames, which are the 2s, the 2, 1, 2, 2, 2, 3, 2, 4, to separate those messages by a certain amount of time and only send so many bytes. Afterwards, you have to wait for another flow control frame to come along. Like I say, if you're on the receiving end and using the Ethernet hardware, don't worry about it. The Ethernet stuff is really quite powerful. I mean, it's already 7 o'clock. I went a little over, right? We're done at 7. Or do you want to just... Does anybody want to get out of here? Otherwise, I'm going into localization using .NET stuff. That was the other...
You ever use out of nowhere, where these certain delightful, they're not, well, codes can be like companies out there. So that basically they're talking about automation for everything. I think Rockwell has covered this being able. So then he subscribes to a bunch of URLs and data socket.
Okay.
Was curious if you'd use that in feed.
I saw the data socket. That was a big one in our Mexico facility because they would have LabVIEW applications and Rockwell PLCs, and they were somehow creating these data sockets to it. That was my only exposure to it.
Yeah, so the difficulty is then you don't understand that's happening or troubleshoot, right? So you got to use Kepler and Kepler applied. It's big enough troubleshoot, but you see the live data and then verify your detection. Otherwise, you don't know where these temperatures just show up. You have
Right.
So, but on the other hand, if you got multiple different devices, it might be a nice solution. So you have to implement it to a bunch of lab Nico. Then you just have a single way of communicating to the client. You just send it in TCP messages, either reads or or whoever read it or thing that style work. I don't know if it's used enough. It's an interesting solution, but I'm curious, be able to see everything lab troubleshooting.
Right, like everything I've done, well, not everything, but most of them, I've had the programming environment for the PLC, so I can see the live data that way. Another one I want to say as a good practice that I try to use is put a heartbeat on the messages. So on the PLC, use its second counter or something and have that as one of the data elements. And same thing on your data going down. If you're using cyclic, have a rolling counter going. I know the PLC is always going to be monitoring that connection, so it'll be throwing error bits if it loses the Ethernet IP. Modbus, I don't think it really cares if it loses it or not. So there's no bit that says I have no Modbus connection. But yeah, having that some revolving value going between the two will at least knows that connection's live. Yeah. But yeah, being able to expose all of those data elements at once would be nice without having to create a data socket or something for every one of them.
Yeah. Example, you guys understand how to use it. Whether after big rate most rate and it's showing me.
Yeah.
Yes, more money. And her over extreme and consider. I see it all solver.
Yeah, so there's CAN high speed, low speed and fault tolerant are the same thing. And then now, it's been all but high speed, and then they'll put plus FD, so flexible data rates. So that network can run at different data rates.
That's where we find K. Dipkey.
I think high speed goes up to 1 megabit. I forgot how low it can go. I thought low speed got all the way up to 250K, but I could be, maybe it is 125. Single wire is pretty slow. I think that one can only get up to about 100 something.
We get back to the PCI. C3.
Yeah, the C series module, yeah, it's an XF, it's a CAN controller and a module, and then your cable is the transceiver. The only thing that was slick about the PCI one is that it was software selectable between them. And on the test system that we have built, any of the, actually there were several different products, so it needed all three of them. You know, this GM1 used single wire, this GM1 used high speed, that Ford one used low speed, or that key used this. So it was awesome having that hardware in there where, again, that's on your...
This is serious one of it. Yeah. Low speed. Low light connectivity.
Yeah, so through this cluster property here, you could basically say what it is, and then in your application, you would know to flip it to single wire, flip it to low speed or high speed. So, or through some type of config file.
Two. We'll overview it. It's
I don't know. I mean, apparently there's a standard out there. Just got to create it and do it. I mean, whether it'll meet the real-time requirements, I don't know, but it's just messages going back and forth, and I know it can do that. Just got to format them right. All right, I'll buzz through this a little bit quicker. Had an application come up where needed to basically produce something that would go around the world. And one of the big things was they didn't all speak English. Imagine that. And the people operating this were not, they're not highly educated to where they would be multilingual. So it needs to be in their local language. As long as it's been on that roadmap, it still hasn't gotten any closer, I don't think, but LabVIEW supporting Unicode. I know when NXG came out, it supported Unicode. I believe the G Web development suite supports Unicode, but I'm not positive. I haven't really played with it much. I tried it with NXG, but unfortunately there were too many other shortcomings of NXG to really implement the project correctly. So there's a couple of toolkits out there. I want to say one is from like a company like CEA out of Germany or somewhere. Pardon? SEA. C. Okay. And they have a toolkit that you can do for localization. And then there's I think there was a JKI one for it. What I found that was with a lot of those toolkits, they required the Windows regional settings to be in the local region. I'm going to tell you this, much like you said about project providers. Be really careful if you're in your programming environment and you change your Windows regional settings, because that changes how your strings look. It doesn't necessarily change your data, but all of a sudden I had event structures with strings, in there, and it changed to Chinese on me. And it took a long time to get all of that stuff to go back. Even after just going back and changing it in the Windows, it was pretty much screwed. But yeah, it really needed to support UTF-8. So there's a bunch of different Unicode standards out there as well. But yeah, UTF-8 is the one that's, I think that is the good one, as far as I've seen anyway. ASCII, what LabVIEW does use, is got 128 characters, so I can pretty much cover all the Latin alphabet. That's about it. If you go into the LabVIEW INI file, you can put in a token, use Unicode equals true, and then that'll change it all to UTF-16. So every character is 16 bits, and it's only a little endian. Of course, now when you're talking about that, you got to worry about your byte swapping. So now every character uses 16 bits, and what I've noticed that when you do that, some of your strings and your labels will appear as if they have a space in between the numbers, because now instead of there being a single byte per character, there's 2 bytes, and you have a 00 usually, because everything is Latin and everything is handled by just a single byte, and that null character seemed to just space the characters out a little bit, so it looked weird. Didn't hurt anything, but it didn't look good. And it still couldn't support everything without changing the Windows regional settings to get the actual localized characters in there. So I said, to heck with it. .NET works, and you can drop a .NET palette or a .NET container onto a LabVIEW front panel. So maybe this could do a thing. One tip: install Visual Studio. They make a community edition that's free. As long as you're not making over like $1 million a year and you don't have 100 developers in your company, it's technically free to use all you want. You can make stuff with it, make executables all you want. But that was really nice for me, because that one has in their IDE, you can, just like you're creating a front panel in LabVIEW, you can drag things over, you can resize them, and they've got a nice little properties window where you can change your font type, your colors, your sizing, how it docks, how it grows and shrinks as your window changes shape. So what you'll see when we're doing this in LabVIEW is everything .NET is done through property and invoke nodes. So you've got to be digging through menus, and it's a little bit cumbersome. And then my other tip is create a database with all the translations, which is basically what SEA did. I mean, they do it a little bit more with, I believe, with a user dialog. But yeah, you're basically creating this thing of, here's all the captions of my front panel controls that I want to change. And if I'm English, use this. If I'm French, use that. If I'm this, use that. So basically do that same thing. The way I happen to do it, and I don't know if it's the best way, I use a SQLite database. SQLite encodes all text as UTF-8 to begin with. I would create a different table for every screen or every UI screen that I would create. So I knew that if that screen came up and it was a certain language, all I had to do was run a query, give me that table. Here's my captions in this column, and here's the selected language. So bring all that back. If I don't have a translation, default to English. And then as a new language is added, you just need to update the database. Your code, your program should already be able to handle that, okay, now it's French. Well, I should have a column for French on that screen. If I do, display it. If not, revert to English. The other option is to use icons. Forget words. Did a whole lot of that too, but sometimes you just need a label. Can go into here. So here's LabVIEW app. There's an English, Spanish. Look at that, Chinese, without having to go back and change any of my Windows settings. Found out Yiddish, Arabic. .NET supports the right to left as well. The Arabic language, they write left-handed, right to left. Definitely something that the LabVIEW stuff will not do. So there it is, it works. All of those say hello world, by the way, according to Google Translate. Yeah. Right, so then we get into that. So now I'm like, okay, so I can use a .NET label. What else? Do I just stick a whole bunch of these .NET containers? Because for each one, you would have to drop down a container, .NET container. And then within that, insert something. So yeah, if you had a numeric, you would have to have an accompanying panel. Well, then I said, heck with it, I'll just make the whole damn UI out of .NET elements. So I did. Don't have that code anymore. That's with CFR, but it looks really good. Some other nice stuff, like this is a what's called a table layout panel. So you just specify how many rows and columns you want, and you can specify. Here I just said I'm going to have 2 columns, 4 rows, anchor, doc, fill the whole thing. And then when I'm adding columns, you have several different size types. I happen to pick percentage. So make each column 50% of the total width, and make of the 4 rows, make each one of them 25% of the total height. If you're trying to do that with LabVIEW, you get to do all the math. But now as I resize, that'll just handle it for me. And this is just a layout panel, so there's really nothing there. I can insert buttons into some. I can insert graphs into some. So that's what I had on this particular UI is there's 4 graphs. And as you resize, all 4 graphs are going to maintain the same proportion to one another because they're part of this table layout grid, or table layout panel. I didn't have to mess with any of that math to do the resizes. Yeah, the graphs are also .NET. So yeah, the entire UI, other than the buttons, like on the side, I have a strip of radio buttons with icons on it that basically act as if they're tabs, and they just change what VI is loaded into the subpanel. That's most of the window. But yeah, each one of those is really one giant .NET panel. That's the entire screen, and you programmatically populate that panel. And if you happen to look at it's like a UI, a breeze like look at. I don't remember exactly this, but like one of the out it, you tell it the VI you want it to center on it, and it'll automatically center like the dial. So like we have a creative for say subpanels on there. The dialogue will pop up over the subpanel. Oh. I see. Yeah. Haven't heard of it. Okay. Within it then too, you have a ton of these actions. Like there, I can click on a button and it can do something. So that's where we start getting into I'll just go back here. Benefits. Every single thing supports the UTF-8. So that's labels, string controls, combo boxes, data grid views, all the graph elements. So your axes of the graph, any annotations that are on the graph, every single thing would support this UTF-8. So that was great. It does proper screen resizing. So this one, we would ship it with a monitor, but they may stick any monitor that they want on it. I wanted it to grow and shrink correctly and still look good. It does all that, and I didn't have to program any of that. That's all kind of baked in. I used a lot of the table layout panel, but there's also something called a flow layout panel. That's more for if you're on your phone and you switch from landscape to portrait, it would rearrange all the stuff to line up with that particular thing all automatically. A very cool thing is you can add control elements dynamically. So with the EXE running, you could just say, create a button, and you would create a button, have some actions. You're in LabVIEW, if you wanted to have that ability, you're pretty much just hiding a button, or you're showing them way off of the screen, and you're just moving it down to where they can see it. And you don't use the event node or the event structure for any of this stuff. What you do is you run these event callbacks. So, but yeah, they can handle just about any type of user interaction with a mouse over, mouse down, mouse up, lose focus, get focus. I'll show you the drop down of just what a button can do. Drawbacks though, it's a lot harder to program than just LabVIEW. LabVIEW is very simple. You want to write something to a graph, you just write an array to a graph and it plots it for you. You want to update a chart in .NET, it sucks. Which brings me down to that other bullet point where it is slow. You have to remember to close all your references. So in .NET, you're creating these, you're starting with a constructor that's a label, and you're creating these, you're modifying it with property nodes and invoke nodes. If you take that init label and you stick it into something like a panel or a table layout panel, you need to close that reference. That reference is now part of the panel. Don't worry, you're not going to delete it when you close the reference. If you don't, you create these memory leaks. Didn't know all that, and I had graphs updating on the screen, and after a couple of nights of that just sitting there doing nothing but updating these graphs as data was coming in, I would get a memory leak. And it wasn't like a line graph. It was just a bar graph, basically a progress meter with a whole bunch of text inside of it saying what's going on. Just doing that because as I was manipulating it, I was opening these constructors, not knowing that if I didn't specifically close that reference, that it was creating copies every time. So remember to close everything. On very basic hardware, like particular application ends up running on a very simple OnLogix with a little Atom CPU on it. It does appear very slow, and that's because the UI builds at execution time. So the UI doesn't get built until I call the VI that says, with this panel, create all of these elements and insert them into the panel the way I want you to do it. That's when all that runs. So when they're first opening the application, it appears slow and sluggish. Once it's run and it's built, then it's just there in memory in the background, and you can flip through screens pretty fluidly. But that first time, it seems like it's really slow, but that's just because that particular computer takes a long time to build that panel. On the laptop, I noticed no big difference. You would click on it, and it would be there almost as fast as you would normally see with a LabVIEW application. And yeah, right now, plotting is super slow. But that got me to another point where, why was I trying to plot 10,000 points over a 2-inch area on the screen? I don't have 10,000 pixels there, so I can't see it anyway. So I just started doing some resampling at a much different data rate. As far as the picture on the plot, it looked exactly the same because, again, we don't have enough pixels to show that. So that was about the only math that I ended up having to do. Is when I was doing a plot, I would see how big is that plot, how many pixels wide, and I'd make sure I wasn't writing any more of those than that many data samples to it. And that sped it up a lot. There's also some things in there. Every plot, it's much like Excel. If you want to add a second plot, you add another series. It's the same in .NET. You're plotting a series of points. And what you can do is have two series on a single graph. So while one is being displayed, in the background, you're plotting the next series, and then all you're doing is flipping which one is visible at the end. So there were ways to speed it up. It would have been sweeter though, in LabVIEW, I just ran right to a graph. The damn thing is drawn really fast. Anything you find on YouTube when they're doing these examples with graphs, they do this data binding thing, which I haven't figured out. But they basically create a table of data, either a database or something, and they just say bind that graph to that table, and they don't mess with it anymore. The graph is always redrawing if the data in the table changes. That's really it. But yeah, so these callbacks. So that button, I put a mouse clicked event. Maybe that. Pardon? Oh yeah. So that was going to look really funny because well, the block diagram will look normal. But what I have is all the strings are in hex, or displayed as hex. So if you go to translator, or exclamation. Check. Sure. So if I were to copy that, yeah, it works in there. I guess it's all ones that can be displayed. It's only 2 bytes. Not bad. Need a different example. Georgian? Oh yeah, that ain't gonna make it. So now it has no idea how the heck to do that. So you need a middleman, which is Notepad++. Paste it into there, Notepad++. You can see down here it does do UTF-8. And then there's, I think it's there right away. Otherwise, it's a plugin. But you can change it to the straight hex code. And then copy and paste that in to your string constant. Now I was using string constants in this because I was just trying to make a quick demo. But like I said, SQLite database uses UTF-8. So all text that's within SQLite is encoded as UTF-8. So you could directly copy it from the Google Translate and paste it into the database if you got like we use SQLite, or I use SQLite Expert. No, I don't want to update now. There's that should have Evan. From here, nice that my mouse click is echoed. So yeah. And then straight from there, you're reading it into LabVIEW. But when you do that query, I mean, that string is really just a whole bunch of hex bytes. You're not looking at it anyway. You're not writing it to any LabVIEW control. You're writing it straight to a .NET label or something like that. But that's how it did that one. So I found a little bug along the way. If you just drop a straight label into the .NET container on the front panel. So if I do that .NET container and insert a label. Here, yeah, let's say I want to do a That's where I say it's fun when you have to find out what the heck the names of all these things are. History. It makes up. You can see it's not printing at all. That label that I just made definitely isn't working right. But let's just, for fun, make that the English. But if I make it a child of that panel, then it prints all the code out, or prints all the characters out correctly. So I don't know why that was. The only one I found that issue with was the .NET label. If I just went straight with a label into the container, and if I went with a combo box straight into the container, the item list. So when you hit the drop down, sometimes that wouldn't be printed right. But if I made them a child of a panel or a table layout panel or anything like that, it was never an issue. So I just said, okay, there must be something. It must be inheriting something, and went with it. So that's why that label is a child of a panel. For the for the button callback, you drop down one of these, which is a register for registry event callback, and you wire the reference into the event, of course, because that's exactly where you would sync the wire reference in. So don't wire it into this reference, wire it into the event. But then that gives you all of this possibility for how to respond to something happening with the button. And that's just the button one. But yeah, mouse double click, mouse clip, leaving it. Drag drops, all sorts of fun stuff. So I just did the mouse click. Well, here I'll do a mouse double click. And now it's looking for a VI ref. Right click on it and say create callback VI. You must say this event before doing that, and you must wire in your user parameter. So one of the nice things to do is usually these are queue message type handlers. Wire that queue reference in. So if I do, the queue. Sorry, this is going to be a mess. So if I do my create callback VI, you see I get that queue reference in. So whatever you have wired to user parameter will come in. And then in here, you've got references to the control. That'd be the .NET one. Some event data. This is usually an E and a unbundle. Yeah, one will be the sender and one will be E. I thought about learning a whole new language so I can make better sense of all this stuff, but excuse me. Either way, I can do a NQ. It doesn't my give them good names because you're going to end up with a whole lot of callbacks. And on the other end, you need to unregister and then close that callback and then do something called a garbage collect. If you skip this, which I will just for demonstration purposes, go. Yeah. So there's my single click. Slowly do I have to click the double? All right. Thanks for failing me again. Fine, let's just get rid of that. A bunch of errors. Lead. But you see, I commented out that garbage collect. This callback VI is still running in the background. Can't abort it. The only way to get it to stop is to close LabVIEW. So remember to put a garbage collect at the end of your VIs. Wait. Yeah. Yeah, do you remember to close all references? Yeah, remember makes it easy. Yeah. Thanks. Oh, yeah, I know why. So that. We'll run. I think up that ball we going. The Control Shift W. Yeah, everything LabVIEW that's open will come up so you can pick things and call it that.
Zoning status.
That I don't know.
Eventually goes to these dogs. showing that right. Doesn't buddy.
Because there was another one I downloaded. There's another one that I downloaded and kind of modified, but it was like what's running.vi. And it would come back with a list of all the things that were running, and you could set a Boolean to close it.
Right. Yeah, and then it goes out, you maybe that when this is.
Yeah, when it would miss the close. So, give that and do all one button. Alt, double. You're Yep. So I was gonna. Now it's still coming off of here, so that's wild. All right, don't use the double click event callback because that is really sensitive. Pardon? Off with that. Oh, sorry. Yeah, now you can see with the garbage collect at the end that this VI did actually close in the background. So yeah, it was a struggle. But the application does show any language you want it to show. The user can either be typing in any language. I mean, anything they were typing in was really just stuff that was going into the database. They weren't manipulating how the program ran. You had to be careful about those kinds of things. But yeah, a fully localized application technically made in LabVIEW.
No, that's by basically doing things.
Yeah, I used the table layout view a lot, just because, say that one would always be right. And the graphs are really nice too. When you were resizing them, if it got too small, it would start changing how many, your axis labels. Instead of showing every one, it would start showing every 5. It would offset them. So you get like 1, 2, 3, 4, so that it could shrink all that text into that tight spot. So somebody put a lot of effort in all that.
Right, symbols or
If they're buttons, I prefer symbols. I'll always go with icons on buttons. But like I said, with the labels, axis labels, that kind of stuff, you can't really get around that all the time. Yeah. Error messages. Hey, you're out of fuel. I mean, you got to explain that in a very clear way so that they know what to put more fuel in. So, all right, that's everything I got. I know we're a good bit over. Anybody still online? Couples?
So